What's up, team? Today we are talking about parallel lines. You see the learning target right above me. It says I can solve problems including pairs of parallel lines with a transversal. So let's we basically know what parallel lines are, right? They're lines that never intersect. They go straight. Even no matter what the slope is here, they're never going to intersect. But let's get a more formal definition here, and we're going to talk about transversal as well. So two lines are parallel if and only if they are in the same plane and they never intersect one another. So there's a biconditional statement there. And then we're going to talk about transversals. A transversal is a line that intersects two or more lines in the same plane. And we are going to talk specifically about the relationship between a transversal and pairs of parallel lines. Okay, let's dive right in. So what we have here on the board is we have two parallel lines with a transversal. So let's try to understand before we start doing any math. Let's try to make sure we see what's going on here. So we've named these lines A and B just arbitrarily. It doesn't matter. We have line A and line B. Normally we're used to seeing lines, in terms of two letters and the bar on the top with the arrows at the end. That is a great way to describe lines. In this case, we don't have those points on the lines, so we just named it AB and we named the transversal C. These red arrows here, obviously they won't always be red, but in this case they are. When you see arrows in the midst of a line like this, not at the ends, it means that the lines with the arrows are parallel to one another. So this is a set or a pair of parallel lines. Sometimes you have more than two lines that are parallel. In this case, we have just two. And then we have some line that goes through them. And then we named all of our angles after numbers. So we have angles 1 through 8 here. And what we're going to examine in today's lesson is the relationship that these angles have to one another. There are lots of different pairs of relationships, and we can determine angle measures based on these relationships. Okay, the first relationship I'd like to talk about is corresponding angles. Corresponding angles. So a pair of corresponding angles is two angles that are both on the same side of the transversal. So what I mean by that is these angles 1, 4, 5, and 8 are all on the same side. And in this case, they're on the left side of the transversal. And then 2, 3, 6, and 7 are on the other side of the transversal. So corresponding angles are angles that are on the same side of the transversal, and they also have the same relationship with the parallel line that they are touching. So for example, angle 1 and angle 5 we would say are corresponding angles because they are on the same side of the transversal as one another, 1 and 5, and they are in the same place in relation to their parallel line that they are touching here. So they are above the parallel line B, and angle 1 is above parallel line A. Now there are lots of other sets of corresponding angles here as well. We would say that 4 and 8, angle 4 and angle 8 are corresponding angles. Same side of the transversal, but they're both below their respective parallel lines. On the other side, angles 2 and 6 are corresponding, and then angles 3 and 7 are corresponding. So corresponding angles always come in pairs. We don't list more than two at a time when we talk corresponding angles. The relationship that corresponding angles have to one another is that they are congruent to one another. So we don't know any angle measures here, but we know that angle 1 has the same measure as angle 5. Angle 4 has the same as angle 8, 2 and 6 are the same, and 3 and 7 are the same. And you see that above me here. The next angle relationship I'd like to talk about is another set of pairs. All of these are going to be sets of pairs, or sets of two. So the next one is called same side interior angles. Same side interior angles. So let's use the title of that to try to interpret which angles we're talking about here. So same side refers to which side of the transversal they're on. In this case, it's left or right. Sometimes it's above and below, whatever the case may be. In this case, it's left and right. So same side interior angles are on the same side of the transversal, and they are interior, so they're inside of the parallel lines. So in this case, the ones that are inside are angles 4 and 5, and they are also on the same side of the transversal. So we'd say 4 and 5 are same side interior angles. In the same way, angle 3 and 6 are same side interior angles. The key things with these is that they are on the same side of the transversal and they're both in between, or they're inside the two parallel lines. The same side interior angles have a relationship that their angle measures add up to 180 degrees, so they are supplementary. The third angle relationship, a third of 5, so if you're keeping score at home, there are 5 total, and this is number 3. The third one is called alternate interior angles. Alternate interior angles. And so what we mean by this is alternate, that's, one's on one side, one's on the other, so they're not same side, they're on alternating sides. And they are inside of the parallel lines. So in our example here, we'd say angle 4 and angle 6, that pair of angles, are alternate interior angles. They are on opposite sides, or alternating sides of the transversal, but they are still inside of the parallel lines here. So 4 and 6 are alternate interior angles, as are angle 3 and angle 5. There's 2 different sets of alternate interior angles. The relationship that pairs of alternate interior angles have is that they are congruent to one another. They have the same angle measure. So angle 4 and 6 have the same angle measure, and angle 3 and 5 also have the same angle measure. Relationship number 4, so 2 to go. We have same side exterior angles. Same side exterior angles. So let's try to interpret that a little bit. Same side means same side of the transversal, either both on the left or both on the right in this case. And exterior. So exterior means outside. So for our example here, we'd say angle 1 and 8 are same side exterior angles. They're on the same side of the transversal, but they're on the outside of the parallel lines. So angle 1 and 8, same side exterior angles. In the same way, another pair of same side exterior angles is angle 2 and angle 7. They're both on the outside of the parallel lines and on the same side of the transversal. The relationship that same side exterior angles have is that they are supplementary, so they add up to 180 degrees. Our final angle relationship that we have is the alternate exterior angles. Alternate exterior angles. So alternate exterior angles are on opposite sides of the transversal, so one will be on the left, one will be on the right, and they'll be on the outside of the parallel lines here. So we'd say angle 1 and angle 7 are alternate exterior angles, just like angle 2 and angle 8 are alternate exterior angles. So they're like the exact opposites of one another, the furthest ones apart. Those angles are congruent to one another. They have the same angle measure. So those are the 5 new relationships of angles that we're here to learn today, that are created when 2 parallel lines have a transversal that goes through them. Now, all of the other angle relationships that we learned are still valid here. So for example, vertical angles are still congruent to one another, even though we see them here in this new context. So angle 1 and 3 are vertical angles, and they are still congruent, same as 2 and 4. And then 5 and 7 are vertical angles, 6 and 8 are vertical angles. Straight angle, or I guess other supplementary angles, in this case, all adjacent angles, when you have a situation like this, are supplementary. Meaning angles 1 and 2 are supplementary, same as 3 and 4, but also 2 and 3, they're going to be supplementary to one another, and 1 and 4. So all these, there's all these angle relationships that are created, things that we've learned before, but now we're connecting some new dots. Okay, let me know if you have some questions. I believe in you. You got this.